Good morning. Today, for the tutorial session, we are going to solve two questions, question 2 and 3 of the tutorial. The rest is going to be for you to practice and get more familiar. Let's start with question 2. Basically, we have a tank with this circular shape at the side, and everything is food, but it's okay. And consider the depths for the tank 1 foot. So all the calculations will be 1 foot. The question says find horizontal and vertical components of force that water exerts that object. So horizontal and vertical force applied for that circular shape. What's the first step? Cut that part, put it aside, draw a 3 by diagram, the rest. I didn't know all the forces we have from that side. What else? Wait. Those two must be nullified in horizontal and vertical forces. Good. That's it. Do you have one horizontal problem? For the one. What else? Okay, this is a warming up question, so it's okay if you don't remember. We usually cut that piece and put the forces or pressures on that cutted surface because we want to simplify. We cut that piece. So, okay. So this is the button. You have force pressure here. And those two forces must be nullified with some horizontal and vertical force from the starter. Like that. And then, because we have water inside, you're going to have weight and pressure from the side of the refrigerator.
This might be 9 feet or this might be 3 feet. This is 3 feet. Or do you add the
Which height?
uh,
The total is 6.
so it'd be 6 plus 3. Oh, no, it's just 6.
Wait, we need gravity. We need gravity.
Okay, which height you're talking?
And then that would be
Right from there.
that's how you
Oh,
calculate.
no. Where's the one? I'm not good at that. Do you remember where we put X1?
Yeah, first one base.
Yes, processor base.
But do you have a little more?
62.4 meter.
We keep it.
It's gallon.
Do we keep it as?
Just use it as gallon.
Oh, so it'd be 64.
62.4 pound per feet cube. Yeah.
Okay.
If you're right.
No, yeah, that's what you want gravity.
So, gamma for water is 62.4 pound per feet cube. What's the formula for the power? No. OG. HC. Come on. HC. What is HC?
Would be
It stands from.
the centroid.
Okay, what's the stand from centroid? What is the distance from centroid?
It would be
Yes. Okay. Why?
It would be on the center of the. It has the center of the bulge. Oh wait, no, that's the radius.
Like the phone. Okay, good time. This is in terms of so rho G is I should have changed all this back. Times, okay, plus. What is the weight? Did you find the weight? Okay, Maria, what is it? How many pounds?
3,528.
It's too much. So 62.4 times volume. Pi r square. Okay, maybe I made a mistake. Yeah, that's why I was checking. Okay. So
That's quite out there. What are we doing?
So, I want to start the second question. Let me solve this question. Let's focus here, and then we remember what was the procedure, and then we can do much better for the other question. So, basically, for this case, I'm going to cut this area of interest and draw a free body diagram. So this is the area of interest, and this is half a circle. Okay, so first I'm going to have weight applied to the center of gravity. Let's call it W. And from the water, I'm going to have a pressure from the left side. Let's use FR and red color for that. And those two, vertical and horizontal forces, must be nullified with some FH and FV vertical forces to nullify, otherwise it's going to move. Okay, so for the weight, we know the formula is gamma times volume. Gamma is 62.4 times volume, which is pi r squared divided by 2 for half, multiplied by 1, which is the 1 foot, the depth. So this is going to be 882 pound. And for the resultant force from the left side, Fr, rho GH, again I'm writing C red, not to forget this. So rho G is 62.4 and H is distance between centroid and the surface of the water. Which centroid of which geometry? The rectangular geometry. So if I want to draw 3D, I have something like this. I'm talking about this geometry because that resultant force applied to that flat surface. Because sometimes I have seen many students applying inside and then the surface area of that. No. We're cutting this out because we want to simplify everything and we work just around it, nothing inside. Okay, so it is going to be this distance, which is 6 feet plus 3. 6 plus 3. And of course I forget area here, and area we talked, this is the area, times area is going to be 6 times 1, and the value for this is going to be 3,370 pound. So FV is going to be equal W and FH is going to be equal FR because these are the only vertical and horizontal forces. Okay. So now, any question about this one? Good. Let's go with this question. Question 3. Three gates of negligible weight. So those gates, they don't have any weight, are used to hold back water in a channel of width B as shown in these pictures. The force of the gate against the block of the gate is R. So we have a force here for all of them, which we are going to call this force R. Now, the question forgets to tell you what we are looking for. Find R.
So I'll ask, determine in terms of R force against the blocks for the other two gates.
Determine in terms of R the force against the block of the block for the two other gates. Yeah. Sorry, my print there was nothing there. Let me read it once more. Force against the block of the gate. So start with B because it says the force against this block is R for the B case. So you can calculate R first and then go for A and C. Okay. So The original case is B. We have a block in front of the gate, stops the gate from opening because of the water pressure from the right side. The force of the block applied to the gate is R. So do the calculation for part B, find R, and then find the force of the block for these two variations of that in terms of R, which is. So start with B and find R, then the rest will be easy. Again, draw free by diagram and the rest. For the B. Which part is confusing? They're not same. No. For example, some of them, if you cut the part, they're going to have water, some of them they don't. Part A, B, just flat surface. A has some water over the gate, totally different. Start with B. Find what is the force block applies to the gate.
So this be normal formula.
It's like a really, we solved a lot of these type of questions. So we will have pressure from one side, block is supposed to move that way.
So,
H? No, just in terms of H. So it's like a parametric solving. Use H and B and calculate what is the force block applies to the gate for part B, just around the gate. First start with B to find R, then go for A and C. So free body diagram for the gate. Okay. Where is the result? No. No. What is the position of the result? Where is that? Yes. We are moving now. Did you draw the diagram for the gate? Just flat the straight gate. Free by there. No. You have pressure outside. You put the result levels at the bottom. Center of pressure. Gradually pressure increases, it's a triangle. So it won't be at the center, if you go to that center, good. Did you remember? Okay. Good. What about the force from the block? Yes. Now you have two forces. Find that one and find the position. Yes. This one definitely is at the bottom. So how you can find one? This is also control what, right? And you want to find this. Good to remember. Okay, did you find this setting?
This one.
The fourth step here. Digital platform settings. Yeah, times a view, times a view. It's forced. It says height is h, depth is b, width is b. So b times h. F. So the first part of this question is the one we solved many times. Very easy. Okay. Okay, this is, yeah, okay, you use, okay. Shouldn't be, you can get from others. You know, you can control. Yeah, sure. Yeah, for gamma, please don't use any number, just use gamma. It confuses me. Did you find this? Yeah, there you go. Gamma, rho g h, it is h times b. B is, and the question says width. Width. So I expect you find R equal gamma h squared b divided by 3. Check if you find the same thing. Say, working the bar has two h from one distance and second cancel from the other station. At b times h. You can say that's all. Make mistake here before doing fine like that. Okay. So this is correct. Here, what is the position? You can calculate from what on. Or say to the position. Yes. Okay. I'm going to solve first part, and then we can go for the second part. Okay. So, as we talk, we need to draw a free body diagram for this gate. This is my hinge. Let's call it H. Because of the water pressure from the right, I'm going to have this triangular pressure from the water, and resultant force of that pressure, which is going to be here, Fr. From the block, I'm going to have this force. Let's call it R. So the magnitude of resultant force is rho g hc area, or gamma hc area. So gamma hc is going to be h divided by 2. Area is h times b. So we found the magnitude of Fr. Gamma h square b divided by 2. Done. Now I need to know the position, which is yr. This is the distance, we called it yr. So yr is going to be 2/3 of h. Or, like your friends, you can calculate using yr formula, which was yc plus ix divided by area yc, which is going to be 2/3 of h. Then we are going to find moment about h. Why about h? Because we have this force h in x direction and force for h in y direction. We want to get rid of those. So summation of moments about h must be 0. So the force from the block R times the distance from h, which is h, must be equal the resultant force, gamma h square b divided by 2 times the distance, which is 2/3 of h. Therefore R is going to be gamma h square b divided by 3. Okay. Now we have the magnitude of R in terms of the parameters we need. Now let's go for part A, the drawing A, and find the force block applies here, then convert it in terms of R, because all the calculation is going to be in terms of gamma H squared and B. So find what is the force block applies to the gate for drawing A, or section A. Be careful about the area you're cutting out. When you're cutting out, you need to have all the involving section in that part. Everything is going to be similar to the previous 3x diagram, except you have some water inside, so weight of the water is going to be involved.
How many stroke are going to be used?
Why?
You're going to use
So you have 2 H here, 1 H here, 1 H there, so these two. Yeah. Not this one. Yeah. Regulate. Strong. Because the formula for pressure is rho G H. When H increases, pressure increases. Right. This is a very interesting question. Make sure you understand all the details about hydrostatic pressure. It does not. So all is going to pressure. We didn't get it. Just this wall has pressure.
to be the exact
Yeah, exactly. That's pretty good. Good. Very good. What is this for? Result.
that's
In the water. So you have the whole pressure. I think comfortable. So the section you're selecting is going to be this section. So you have
format.
Yeah.
Yeah, exactly. So you do it the other way. Which one is B? This is A. A, A. So, this is like this. You just mirror. And you find it will give you the center rate of the, it's going to be 4 divided by 3 pi times radius. It's the center rate of the x times radius. 3 pi. Okay, same talked about. Don't go inside, just stay outside. Okay. So this is angle. What's the pressure there? And you have to work out this. Okay, we don't have that much time, so I need to a little bit push this part. I'm going to draw the free body diagram to just help. So let's cut this piece. Why I'm including? Because I want to have the force from the block. So I'm cutting from that blue dot. So this is the section I cut from the tank. So from the right side, I'm going to have this pressure exactly like the previous part, and the resultant force is going to be here, Fr, exactly same as the previous part. I'm going to have at the center of this quarter of circle, I'm going to have this weight, and this distance is 4 divided by 3 pi times the radius, which is h2, h divided by 2. And where is the hinge? Hinge is here, h. And I have this fhx and fhy there. So we have one more force. Where is it? From the block. Let's call it fb. Again, we can find the moment about h to get rid of those forces, and only unknown is going to be fb. Okay, any question?
Can you find the center of that semicircle?
It's like in the tables they give us.
What's the equation for that one?
For
the eye of it, so the measure eye.
this is centroid.
Isn't that what that
Mm.
is?
No, centroid is different than moment of inertia or YR. Centroid, for example, for the square, centroid is center. For circle, center. For triangle, 1/3 from bottom. Center of pressure is something else. So, Fr is going to be exactly same as the previous one. Gamma h square b divided by 2, and the position again exactly same. For W, we need to find gamma times volume, which is going to be gamma times pi h divided by 2 square divided by 4 times b, and this is going to be pi gamma h square b divided by 16. We found so weight Fr. Now summation of moment about h must be 0, so w times h2 minus that distance plus Fr times the distance must be equal Fb times distance. And if you calculate, Fb is going to be 1.17 R. Why? Because R was gamma h square b divided by 3. Okay, now let's go part C. Any question about this one? Question?
So it's just, so the main difference really is just the weight.
Weight, exactly. Yeah.
The area,
This area?
yeah, it's like h where we,
This area is the rectangular area, b times h.
yeah, like the HC we can take like the previous one, because it's,
Exactly like the previous one.
but the area is like compared to the height of the body is like h by 2, and the center is like h by 2.
Let me show you. So see, same height, same depth. For that, the dot line, same.
So there is no need to take like different from object, like because it's like semicircle.
Okay, so when we're cutting like this, we just care about this part. This part, what is pressure applied to this part? Only. So the pressure applied to the right side is the uniform increasing pressure from the water. Done. Which is same as the flat surface, flat gate. For the other side, we have weight and the other stuff.
But it's confusing sometimes.
Yes.
Sometimes like we take a particular area of the length and everything.
Oh, like from bottom?
Yeah, like that height and YC will take from top to the midpoint of the specified part. But here like we are taking like total.
Part C, you must separate it.
Yeah.
And you are going to see why. If there's a reason to separate it. If it's not, just keep it one. What you try to separate, am I right?
Yeah.
But it's going to be same because you can have this resultant force and this, and then you can add to each other at the end. Just more calculations. So doesn't matter that much, except in a situation the question forces you to separate. So let's go for part C and finish this. We don't have that much time, so let's solve in 3 minutes. So this is our geometry. Very interesting. Now you're going to force to separate. Otherwise, it's a bit difficult. Okay, I will give you 2 minutes and then tell you the solution, which is very interesting. You should be clever about where you're cutting. Do you want to cut like this? Or like this. Which one has some advantage for us? Maria, you should remember that part. We talked last session. What is the advantage of using this cutting for the upper section?
No need to consider the,
You don't need to consider what?
we don't need to consider the
You don't need to consider force. Why?
because it's simply
Why, Maria?
Because the height difference is small.
No. Why the force, the resultant force applied to the bended surface for the upper section won't be that much important for us.
Because it doesn't matter about the shape of the container.
Why is that not below it?
No. Somebody. Maria, you're supposed to tell me.
Oh, I remember I said.
No, we talked last session and said, oh.
I said that.
What type of resultant force we can have for that circle part? Correct? Let's call it FR1. It's going to pass from the hinge. So the next step is find the moment about hinge. So just neglect that part because it's going to pass through the hinge. So really good idea. So don't bother even calculating the bended surface force and pressure, and then the resultant force there, it was the topic of this session.
So then wouldn't it just be like the first one that we did? Wouldn't it just be like B then?
No, because you separated this part, you left with the lower part only. Now I force you to separate. Hello. Okay, let me solve this question and then. So, this is our gate. We are going to have resultant force here, number 1, and another resultant force here for number 2. This orange one is just covering this orange area. And of course, FHX, FHY, and the force from the block, FB. So FR2 is going to be gamma HC area. Gamma HC is going to be 3 divided by 4H times area H divided by 2. Be careful about this. Now I separated, that is why the area is just lower area. So FR2 is going to be 3 divided by 8 gamma H square B. YR2 is going to be IX divided by YC area plus YC, which is going to be, if you calculate, 2836H, and summation of moment about H is going to be equal FR2 times the distance, 2836H, equal FB times H, and FB is going to be 0.7 divided by 8 R. So, if you practice more, you're going to see those points. And whenever we have a circle, always the force resultant force passes the center. Sometimes they are really, really helpful. Okay, thank you very much.